Right, here's a type 2 error question. So it starts off with a completely normal bit. In fact, it sets you up to understand how to do a type 2 error. And that there's a normal hypothesis test, apart from the fact that it's a sample of size 2. But that doesn't make any difference because the population is known to have a normal distribution, and therefore the sample size is not important. In all of higher level, the central limit theorem always applies anyway, so we didn't really have to think about that. It's a central limit theorem question because we're talking about a sample mean. The other crucial thing, of course, is that the variance of the population is known, and therefore it's a Z test. They've set up it for us, and so it's a one-tailed test. And so we have a fairly simple job of finding the critical region. And this is how I would do it. And you want to try and show this sort of level of working. So, first of all, what distribution do we have? Well, they've told us the mean and the variance, but we're taking a sample, so it's the CLT. We're going to use the formula in the formula book for confidence intervals, but it's the same thing, except, of course, confidence intervals are always symmetrical, whereas we're doing a one-tailed test. But nevertheless, we're using this formula here. And so we get this. So it comes out to be that the critical region is that X bar is in there. So therefore, if X bar is in there, then we will reject the null hypothesis. And if it is like that, then we will accept the null hypothesis. Okay, so then we come on to the question saying, what is the probability of a type 2 error? So first of all, what is a type 2 error? Well, you've obviously got to learn this. That is when you accept H0 when H1 is true. So make sure you know that. Accept H0 when H1 is true. It's not a major problem because accepting H0 is normally the neutral thing to do, saying there's not enough evidence to suggest this drug works, so therefore we accept H0. So it's a neutral thing to do, and if you want to reject H0, you can just get a bigger sample or, do something like that. So a type 2 error is this. And what you do is you say to yourself, well, under what conditions would I accept H0? Well, we've literally just done that. So if I basically have to calculate this probability, because this is the situation under which I would accept H0. So what is the probability that X bar is less than 15.01, except I have to work out this probability when H1 is true. Now H1 is that mu is greater than 13. So as a general principle, you can't find type 2 errors, because if H1 is true, we don't know what the mean is. All we know is it's bigger than 13. And so type 2 errors are impossible to calculate as a matter of principle, unless the question is contrived in some way. And here it is, that they simply say, given that the true population is 15.2, now calculate the probability of making a type 2 error. Well, if we know the true population mean, why on earth are we doing a significance test on a sample? Doesn't make any sense, because we know it anyway. So what we have to do is find the probability that X is less than 15 when we have a different distribution, and the distribution is under H1. And so that now this is just a simple NCD question on the calculator.